Welcome to the deep dive. Wow, you really gave us a mountain of material this week. Not just sources, more like a whole dossier, really. It covers this period where AI just seemed to leap almost overnight from the lab right into, well, everything. Real world stuff. We've got deep physics, serious medical breakthroughs, but also, corporate finance details, ethical debates, all sorts happening globally.
The speed was just
Oh,
staggering is the
yeah.
word. And what really stood out, I think, wasn't just announcing new AI tricks. It was the deployment,
Yeah.
actually putting these capabilities into critical systems, into things people use every single day.
Right. So our job here, our mission for this deep dive is to sift through all that, pull out the key shifts, the big strategic moves, and also importantly, look at the friction points, the costs, ethical, financial, environmental that come with moving this fast.
Exactly. We're past the theory now.
Mm.
We're talking real-world impact. It's like a multi-front race is heating up everywhere.
Okay, so where should we start? Maybe with the highest stakes, where AI is genuinely like changing things for people, not just, optimizing ad clicks.
Sounds right. Let's talk health first. What's fascinating is how targeted these applications are becoming. So diagnostics. We saw Google and Yale highlighting a potential new cancer therapy using AI, which is obviously incredible news.
It's huge, yeah.
But the deeper technical piece in the sources was Google Research's deep semantic tool.
Yeah.
This thing is apparently outperforming the leading traditional genomic tools.
Wait, outperforming the standard tool?
Oh, yeah, in accurately spotting those complex tumor genetic variations from sequencing data. That's a very specific, very hard task.
Okay, so that's a big deal. It's not just finding something novel, it's doing the existing critical work better, faster, maybe more reliably for doctors.
Precisely. It gets that crucial info to the oncologist faster, with potentially more certainty. That shapes treatment. And it's not just cancer. We saw Yandex launching an open source AI tool. This one's for detecting infant cerebral palsy.
Wow, how does that work?
It analyzes MRI scans and gets this. It does it in minutes, apparently, with over 90% accuracy.
Minutes. That's huge. Usually that takes weeks, right?
Exactly. Think about the impact for parents, for pediatricians. Early intervention is absolutely critical for CP, cutting that diagnostic time down. It's a massive humanitarian step.
Absolutely. And then there's the delivery side of medicine. Thermo Fisher Scientific. They made a big move too, didn't they?
Yeah, really strategic one. Teaming up with OpenAI, they're embedding advanced AI directly into their drug discovery work, their clinical trials.
So this isn't just a pilot project. This is like full integration.
Seems like it. It's aimed squarely at making the whole process cheaper and faster, getting medicines to patients more quickly, potentially at lower cost.
Yeah.
A major supply chain shift.
Okay, so health is seeing massive change. What about more fundamental science? You mentioned physics earlier.
Right. Let's shift from biology to energy. DeepMind had another really critical advance mentioned in the sources. They're using reinforcement learning to control plasma in fusion reactors.
Fusion control. Okay, that sounds incredibly complex. They partnered with CFS on this.
Yeah, Commonwealth Fusion Systems. The goal is to speed up development of safe, real-time plasma control.
So help me understand this. Reinforcement learning. That's the AI learning through trial and error, right? Like rewards and feedback. Why is that technique so important for fusion?
Well, plasma is incredibly chaotic, unstable. You need adjustments on like a nanosecond timescale. It's just too fast, too unpredictable for traditional pre-programmed control systems.
Ah, okay. So the AI learns on the fly how to manage it.
Exactly. It reacts dynamically in real time, learning to stabilize the plasma. That's a huge step towards making fusion energy actually work, making it sustained and stable. So yeah, cancer diagnostics, CP detection, fusion control.
Mm-hmm.
This is the kind of immediate critical relevance we saw this week.
That focus on, let's call it scientific energy, it kind of mirrors the commercial energy we saw pouring into everyday retail and software. Because while the lab stuff is amazing, the shift in the market this week felt equally huge. AI agents aren't just concepts, they're inside brands,
Right. And the term that kept popping up was agentic commerce. It's important we unpack that a bit.
Yeah, what does that actually mean?
It means the AI isn't just a passive chatbot waiting for you to ask something. It's more like a software entity that can actually do things for you, autonomously.
Yep.
Planning, buying, optimizing tasks.
Okay, got it. And Walmart seems like the poster child for this right now.
Definitely. They're rolling out OpenAI's ChatGPT for things like personalized meal planning, even faster checkouts. They're explicitly calling it a new era of agentic commerce.
That's a massive company betting big. How does that compare to, say, Alibaba? They were mentioned too.
Right. Alibaba deployed large language models during their huge 11-point woven global shopping festival. But their focus seems slightly different, more on boosting search results, making recommendations better. So Walmart's may be more about personal tasks, Alibaba about optimizing the massive flow of commerce.
Interesting contrast, scale versus personalization.
And while that's happening, the creative industries are scrambling to figure out the rules. We saw Spotify working directly with the major music labels, Sony, Universal, Warner.
What was the goal there? To build AI music tools.
Yeah, but crucially, to build artist-centric tools. The agreement they reached focuses on, fair pay for artists, setting clear boundaries for AI use.
And labeling, right, making it clear what's AI generated.
Exactly. Transparent AI labeling was a key point. The idea is to set a standard so creators keep control and listeners actually know if they're hearing something made by a human or an AI.
That seems vital. Is that just a Spotify thing or is it broader?
It's definitely broader. We saw Japan specifically putting pressure on OpenAI about the ethics of its Sora 2 music AI. So this whole intellectual property and labeling discussion is now a top-level international governance issue.
Meanwhile, Microsoft is just relentlessly pushing AI everywhere. Copilot in Windows 11.
Yeah, they're embedding it deeper. Voice, vision capabilities, even acting on your local files. The aim seems to be making every PC an AI PC, even if it doesn't have super specialized hardware.
Sort of democratizing access to that power.
Right. And it's not just for work. They're also rolling out free Copilot tools for schools globally. Customize lessons, help with quizzes, streamlining admin tasks for teachers.
Wow! That's massive scale, integrating into education systems like that.
It is, but all this hyper-integration, it's definitely creating some pushback, especially around privacy.
Yeah, the DirecTV thing. That sounded a bit much. AI-generated ads using customer likenesses, digital avatars.
Yeah, planned for 2026 on their Gemini devices. It raises some serious questions, obviously.
Like, how do they get consent for that? Using my face in an ad, that feels really invasive. Did the sources detail the opt-out process or the legal side?
Not fully. The sources noted the plan was, let's say, aggressive and raised these questions. But the specifics on consent frameworks weren't clear yet. Often the tech moves faster than the rules, right?
True. But people are pushing back.
Absolutely. Look at Pinterest. They actually launched filters so users can minimize the amount of AI-generated imagery they see. Why? Because users were getting frustrated with it. So you've got this clear tension. Companies pushing hyper-personalization, sometimes using your data or likeness, and users saying, hang on, I want some control here.
That tension feels central. Okay, let's peel back another layer. Look behind the curtain at the engines driving all this. The AI models themselves, the hardware. The big theme here seemed to be efficiency, right? Not just bigger is better anymore.
Exactly. Performance and efficiency. That was the clear trend. Making powerful AI run effectively on smaller devices, like your phone, or on cheaper servers. It's about broadening access.
And we saw examples of really tiny models doing surprising things.
Yeah, Mixspread released these tiny search and Colbert variants. And when we say tiny, we mean like 17 to 32 million parameters, not billions.
Okay, that is tiny compared to the big guys.
But reportedly, they're rivaling or even beating much larger models on specific tasks, like long context benchmarks. That's pretty mind-blowing, the performance jump for the size.
It really democratizes things if small models can be that good.
Totally. And Meta's doing similar things with MobileM Pro. That's a 1 billion parameter model aimed specifically at running high-quality AI on the device. No cloud needed. Even Anthropic's Claude Haiku 4.5, which is meant to be their faster, lighter model, showed surprisingly strong performance in community tests, even on weird, tricky benchmarks. The efficiency push is huge.
And the hardware is racing to keep up with making these efficient models run even faster.
Right. Google and vLLM announced a unified TPU backend. So vLLM is software that speeds up open source models. Google has its specialized TPU chips. By optimizing them together, they're claiming up to 5x speedups for running these open models. That's a massive bottleneck being addressed speed and access.
5 times faster. Wow.
And underpinning all this is the chip war, which is just intensifying. TSMC is moving to mass-produce 2-nanometer chips. AMD stocks soared because they're strengthening ties with Oracle and OpenAI, directly challenging NVIDIA's dominance. So you have efficiency gains in the software models, amplified by speed gains in the hardware underneath.
Which means developers building on this stuff need better tools to handle the complexity.
Precisely. LangSmith Studio launched. It's basically an IDE, like programmers use, but specifically for debugging these complex agentic AI apps.
Yeah.
That's a big sign the tooling is maturing, moving from, hobbyist scripts to something stable enough for businesses.
Makes sense.
And CoreWeave's OpenPipe introduced serverless reinforcement learning at scale. RL used to be super computationally expensive, kind of exclusive. Offering it serverlessly just lowers the barrier massively for experimentation.
Plus,
Hugging Face released a simpler framework for benchmarking models, making it easier for everyone to test and compare.
okay, so things are getting faster, more efficient, more accessible, but that speed inevitably leads to bumps in the road, right? The friction points.
Absolutely.
Yeah.
And this brings us to the unavoidable tensions. Ethics, corporate pressures, environmental costs, they all came into sharp focus this week.
OpenAI seemed to be at the center of a lot of that. What was going on there?
Well, multiple things. There's ongoing scrutiny about their original nonprofit mission versus their current structure, including legal fights with critics. But the really big flashing light from the sources was the financial pressure. Reports suggest OpenAI is losing a lot of money, something like potentially $13.5 billion in the first half of 2025 alone.
$13.5 billion, that's staggering. That kind of loss has to force some tough decisions, right? How does that connect to the other stuff?
It seems very tightly linked. That financial urgency is almost certainly driving the push for new revenue, which likely connects directly to their controversial decision to relax some ChatGPT restrictions for adult users.
Ah, okay. So loosen rules attract more paying users.
That seems to be the strategy. They are implementing stricter age verification, they say, but the move immediately set off alarm bells about safety, privacy, potential misuse. Huge debate, lots of scrutiny.
So it feels like damage control then when they also announce they're forming an expert council on well-being to focus on safeguards.
It certainly looks like a direct response, yeah. Trying to manage the fallout from decisions likely driven by financial necessity. It's that pattern again. Push for speed and revenue, then deal with the ethical blowback simultaneously.
And it's not just OpenAI feeling the heat. What about the impact on jobs? Anthropic had some findings.
Yeah, their internal research suggested their AI, Claude, can now automate most routine coding tasks. The idea is it frees up engineers for more complex creative work.
Sounds good on the surface. More productivity.
It does, but the potential downside is serious. If AI takes over the bulk of entry-level coding tasks, where do new programmers get started? There are real concerns that this kind of automation could shrink the pipeline for junior developers, making it harder to break into the industry.
Wait, back up. Most coding tasks. That sounds like a huge claim. Did the sources specify what kind of tasks? Because enterprise software is usually pretty messy and complex, needing human judgment.
That's a fair point. The sources suggested the automation was most effective for things like generating boilerplate code, initial debugging, documentation tasks often given to junior devs. So maybe not architecting complex systems, but it does hit that crucial entry point hard. Senior engineers might get a boost, but the pathway to becoming a senior engineer might be narrowing.
Okay, that makes more sense. A critical nuance. And finally, the environmental cost. We can't ignore that.
Definitely not. The report from Scotland was pretty stark. Data centers there powering generative AI have apparently quadrupled their water consumption since 2021.
Quadrupled. Wow, that really puts the sustainability question front and center, doesn't it? This AI revolution runs on water and power.
It absolutely does. It highlights the hidden environmental footprint that comes with this relentless drive for more powerful, faster AI. It's a direct trade-off we need to confront.
Okay, so let's try to synthesize this whirlwind week. What are the main takeaways if you had to boil it down?
I think three big things stand out. First, AI is genuinely driving massive scientific leaps right now. We're seeing it in cancer diagnostics, drug discovery, even fundamental physics like fusion control. Real, tangible progress.
Okay, science leaps. What's second?
Second, it's integrating into consumer life and business operations at breakneck speed. It's changing how you shop via agentic commerce, how your operating system works with Copilot, how schools teach. It's becoming embedded everywhere.
Right, integration at speed. And
Third, the industry is grappling, very publicly and sometimes painfully, with the consequences of that speed. Intense financial pressures, complex ethical dilemmas like content moderation and bias, workforce shifts, and serious environmental costs, all happening at the same time.
It's a fascinating mix. Because despite all this incredible functional power we saw demonstrated like 5x speedups, finding cancer markers, the sources also revealed this deep uncertainty, almost an identity crisis, within the field itself, specifically around defining AGI, artificial general intelligence. Researchers just can't seem to agree on what it is, when we'll get there, or even how to measure progress towards it.
Yeah, that's the paradox. While the academics debate AGI definitions, what's actually winning in the real world in production? It seems to be the sophisticated but task-specific models, like those Cerebrus retrieval models mentioned, apparently outpacing general assistants, or, as we discussed, those tiny, efficient models suddenly punching way above their weight class.
So that brings us to the final thought, the question maybe for you, the listener, to chew on this week. If these reliable, efficient, specialized AI tools are the ones consistently solving the big critical problems right now, detecting disease, controlling fusion, optimizing logistics, does the theoretical chase for, or even the precise definition of, AGI actually matter less in the immediate term, compared to just doubling down on building the best possible, most efficient tools for these specific, vital, real-world applications? Something to think about, that tension between the grand goal of generality and the practical power of specialized efficiency. Ponder that as you go about your week.